Hello students, welcome back. So we are doing exercise 8a logarithms from ICSE book of class 9, isn't it? So in our previous videos we have completed till question number 6 and today we'll start from question number 7 onward. Okay, so let's begin. So this is question number 1 of 7. We are asked to evaluate. Evaluate means we are asked to find the value of this. Okay, log 0.01 to the base 10. We are asked to find the value of log 0.01 to the base 10. Okay, so let's do this. This can be written as log 1 upon, there is a decimal point before 2 digit, isn't it? So we write 2 zeros. 1 is already in the denominator, so we put 2 zeros, okay, to the base 10. Let me explain this. Suppose we have 0.01 here. We already have 1 in the denominator, isn't it? Because every number has 1 in the denominator. If I write 2, we must understand there is 1 in the denominator. If I write x, then we must understand there is 1 in the denominator. But we usually don't write 1. We must understand this, isn't it? So there is already 1 in the denominator. So what we do is we remove the decimal from the 2 digits in the numerator 1 2. Okay, the decimal point is shifted to backward and only 1 remains here now. Okay, so we have removed the decimal point from the 2 digits, so we must put, this one is already there, we must put 2 zeros in the denominator. Okay, I hope you got this. Now let's write this 0.0000001. so this number also has already 1 in the denominator, isn't it? Every number has 1 in the denominator. So what we do, 1 upon 1 is already there in the denominator, 1, this one. Now we are removing decimal point from 1 2 3 4 5 6 digits. There is a decimal point before 6 digit, isn't it? 1 2 3 4 5 6 digit. There is a decimal point before 6 digit, so we put 6 zeros in the denominator, 1 2 3 4 5 and 6. Okay, did you get me? Yes. Now this 0.00001 01 or 001 or 001, same thing, isn't it? So we don't write these zeros here. So we simply write 1 upon this. Okay, 10 lakh, I think so. 1s, 10s, 100, 1000, 1000 lakh, 10 lakh. 10 lakh means 1 million. Okay, now we remove a decimal point from 2 digits in the numerator, means we put 2 zeros in the denominator. Okay, now since we know that log a upon m, suppose we have log a upon m, then what we do is log a minus log m, isn't it? Division means minus. So this can be written as log 1 to the base 10 minus log 100 to the base 10. Okay, log 1 to the base 10 minus, upon means minus, log 100 to the base 10. Okay, log a upon m means log a minus log m. Okay, now log 1 to the base any number. Okay, log 1 to the base any number is always 0, isn't it? Log 1 means 0, any base, for any base, provided base should not be 0. Okay, other than 0, if other than 0 any number is there in the base, then log 1 becomes 0. Log 1 to any base other than 0. Okay, log 1 to the base x, log 1 to the base x equals to 0. Log 1 to the base 100 equals to 0. Log 1 to any base other than 0 is always 0. Okay, minus log 100. Log 100 means log 10 square to the base 10, isn't it? This base 10 is base 10. 100 means 10 square. 10 10 is 100. 10 squared means 100. Okay, so 0 minus this is minus. Okay, 2 comes here now. 2 log 10 to the base 10. Now minus 2 log 10 to the base 10 means 1, isn't it? Log a to the base a means 1. Log 2 to the base 2 means 1. Log x to the base x means 1. Log of a number to the same base is always 1. Okay, so log 10 to the base 10 means 1. This gives us minus 2 into 1 is minus 2. So this is the answer. Minus 2 is the answer for question number 1. Okay, I hope you got this. Now let us do question number 2. So log, okay, equals to log, this is divide, isn't it? Divide means what? Log 1 upon 8, isn't it? Divide means 1 upon 8. So divide, when we have divide, we write minus, isn't it? So log 1 to the base 2 minus log 8 to the base 2. Log 1 upon 8 and log 1 upon 8 and log 1 divided by 8, same thing. Okay, this log 1 upon 8 is 1 divided by 8, isn't it? So this can be written as log 1 minus log 8 to the base 2. Okay, so we have log 1 to the base 2 minus log, this divide changes to minus log 8 to the base 2. So log 1 to any base is always 0. So this is 0 minus log 8. 8 means 2 cubed. 2 into 2 into 2 is 8. 2 into 2 into 2 is 8. So 2 multiplied 3 times gives us 8. So 2 cubed is 8. Instead of 8 I write 2 cubed. Okay, now we have base 2. This equals to 0 minus means minus, isn't it? Minus this 3 comes in the front. 3 log 2 to the base 2. This means minus 3 log 2 to the base 2 means log of a number to the same base, isn't it? Log 2 to the base 2. This means 1. Log x to the base x means 1, isn't it? So log 2 to the base 2 means 1. So minus 3 into 1 is minus 3. So this is the answer for question number 2. I hope you got this. Now let us do question number 3 and 4. 3 and 4 of 7. Okay, we are asked to evaluate. Evaluate means we are asked to find the value. So log 1 to base 5. Log 1 to the base 5. Log 1 to any base is always 0. So the value of this is 0. Okay, very simple. Log 1 to any base is always 0. Log 1 to any base means base should not be equal to 0. Base should not be equal to 0. Other than this condition, log 1 to any base is always 0. Okay, so log 1 to base 5 is 0. This is the answer for question number 3. And 4, we have log 125 to the base 5. This means log 125 means 5 cubed, isn't it? 125. 5 2s are 10, 11 12 2, 25, 5 5s are 25, 5 5s are 25. So 5 multiplied 3 times gives us 25. So 5 cubed is 125. 5 into 5 into 5 is 125. So 5 cubed means 125. This base is here. Okay, base is 5. Base is 5. Log 5 cubed to the base 5. This cube comes in the front now. Log 5 to the base 5. So 3 log 5 to the base 5 means log of a number to the same base. Okay, log x to the base x is always 1. Okay, if the base is same to log, then that is 1. Log 5 to the base 5 is 1. So this means 1. 3 1s are 3. So the answer for this question is 3. Okay, now let us do next questions. Question number 5 of 7 and question number 6 of 7. We are asked to evaluate. Evaluate means we are asked to find the value of x, isn't it? Oh, we are asked to find the value of this, isn't it? Simple value, simplest value. Okay, so log 8 to the base 16. So to solve this, we need to change this into exponential form. Okay, this is in logarithmic form. We need to change this into exponential form. So let this be x. Let log 8 to the base 16 equals to x. Let log 8 to the base 16 equals to x. Okay, we are supposing log 8 to the base 16 to be x. Now we change this into exponential form and we find the value of x, and x is this, isn't it? So if we find the value of x, then the value of this will be the value of x. Okay, value of x will be log 8 to the base 16, isn't it? So let us change this equation into exponential form. How do we do this? Or this 16 is base, isn't it? We write 16 here. This x will be power now, equals to log 8 will go here as 8. Okay, now 16 to the power x equals to 8. 16 means 2 to the power 4. Now x was already there, we write x. 2 to the power 4 means 16. Okay, 16 means 2 8s are 16, 2 4s are 8, 2 2s are 4. 2 multiplied 4 times gives us 16. 2 to the power 4 is 16, and this x was already there, we write x here. 8 means 2 cubed. 2 2s are 4, 4 2s are 8. 2 multiplied 3 times gives us 8. Okay, 8. 2 4s are 8, 2 2s are 4, 2 1s are 2, 2 2s are 4, 2 3s are 8. 2 1s are 2, 2 2s are 4, 4 2s are 8. Okay, now 2 and 2 bases are equal. This means the power should be equal, or 4x equals to 3. If the bases are equal, then their powers will be equal. So 4x equals to 3, or x equals to 3 is already there. Now we bring down this 4 to the denominator by cross multiplication. X equals to 3 upon 4. So this is a proper fraction. We don't need to change this into mixed fraction. So the answer for this log 8 to the base 16 is 3 upon 4. Okay, because we have supposed this to be x, and x is 3 upon 4, isn't it? So the value for this is 3 upon 4. Now let us solve this as well. So let us suppose this also. Let x equals to let log 16 to the base 0.5 equals to x. Okay, now this is in logarithmic form. We change this into exponential form. Log 16 to the base 0.5, we suppose this to be x. Okay, now we will find the value of x, and x will be the log 16 to the base 0.5, isn't it? So, or 0.5 is the base, we write 0.5 here. Okay, now this will be power, so power is x equals to the 16 comes here. Or 0.5 means 5 upon 10. We remove decimal point from one digit, we put 1 0 in the denominator. Whole to the power x equals to 16. So 5 1s are 5, 5 2s are 10. 1 to the power x upon this 1 upon 2, isn't it? 1 upon 2. This x power is for both 1 and 2 because both are within the bracket. So 1 to the power x upon 2 to the power x equals to 16, means 2 to the power 4, isn't it? Or 1 to the power x means 1 raised to power any number. Please keep this in mind. 1 raised to power any number is always 1. Okay, 1 to the power 0 equals to 1, 1 to the power x equals to 1, 1 to the power 100 equals to 1. 1 raised to power any number is always 1. 1 raised to power any number is always 1. So 1 to the power x means 1. So let us take this 2 to the power x to the numerator. This is already 1, so we need to write that 2 to the power plus x to the numerator. This becomes 2 to the power minus x, isn't it? Or 2 to the power minus x into 1 is 2 to the power minus x. This 1 to the power x is 1 now. So 1 into 2 to the power minus x is 2 to the power minus x equals to 2 to the power 4. So 2 and 2 bases are equal. This means power should be equal, or minus x equals to 4. Now let us multiply both sides by minus sign, or x equals to minus into minus plus x, minus into plus minus 4. Okay, the value of x is minus 4. I am multiplying both sides by minus. Minus into minus x, plus x, minus into plus 4, minus 4. So we got the value of x to be minus 4. The value of x is minus 4, and x is what? Log 16 to the base 0.5. So the value of log 16 to the base 0.5 is minus 4. Okay, so this is the answer. Minus 4 is the answer. I hope you got this. Now let us do the next question. Let us do question number 8. If log m to the base a equals to n. This is the given condition, log m to the base a equals to n. So we are asked to express a to the power n minus 1 in terms of a and m. Okay, we are express a to the power n minus 1 in terms of a and m. Means we are asked to find the value of a to the power n minus 1 in terms of a and m. Okay, so let's do this. Since we have log m to the base a equals to n, isn't it? So this is in logarithmic form. We convert this into exponential form. Okay, or a is the base, so we write base here. This will be power now, and equals to this log m will come here, m, isn't it? So we need a to the power n minus 1. We have only a to the power n. So let us divide both the sides of this equation by a. Okay, a by n divided by a equals to m by a. I am dividing this equation by a, dividing both sides by a. Okay, I can do this because this a and a can be cancelled, so the value of this equation does not change, isn't it? Left hand side and right hand side I am dividing by a. Okay, so the value of the power of this a is 1 here, isn't it? So this means if I take this a to the numerator, the power of the sign of the power changes to minus 1. So base are equal, a and a. This means power will subtract n minus 1, isn't it, equals to m upon a. So a to the power n minus 1, isn't it, upon a means the power is 1, isn't it? The power of this a is 1. We don't usually write 1 because if there is no power, we must understand the power is 1. So when I take this a to the numerator, this becomes, okay, a to the power n upon a. So when I take this a to the numerator, the sign of the power changes to minus 1 because this a has power plus 1. So if I take this a to the numerator, the sign of the power changes to minus 1. Now a same base, there is multiplication sign, so same base means power should be added, a to the power n plus, this becomes minus 1, this becomes a, and plus into minus is minus 1. So this is a to the power n minus 1, isn't it? I hope you got this. So a to the power n minus 1 is m upon a. So we are asked to find the value of a to the power n minus 1 in terms of m and a, and this is the answer, m upon a. M upon a is the answer. This is the answer. Okay, m upon a. Now let us do question number 9. Now let us do question number 1 of 9 first, and then we will do question number 2 of 9. Okay, so given condition is this: log x to the base 2 equals to m, log x to the base 2 equals to m, and log y to the base 5 equals to n. So we are in question number 1, we are asked to express 2 to the power m minus 1, 2 to the power m minus 3, 2 to the power m minus 3 in terms of x. Okay, we are asked to find the value of 2 to the power m minus 3 in terms of x. Okay, so let's use this equation because here we have x, isn't it? Here we don't have x, so we use this one. Since log x to the base 2 equals to m, this is the given condition. Now we change this logarithmic equation to exponential form. Okay, or this 2 is the base here, 2 is base, log x to the base 2 equals to m, 2 is base. Now this m will be power here, equals to this x will go to the right hand side. Now we have 2 to the power m equals to x, isn't it? So we have minus 3, m minus 3. This means we divide both sides by 8. Okay, we divide both sides of this equation by 8. Left hand side we divide by 8 and right hand side we divide by 8. Okay, so this gives us 2 to the power m divided by 8 means 2 cubed, isn't it, equals to x upon 8. Or 2 to the power, see here, 2 and 2 bases are equal, 2 and 2, this means powers get subtracted. 2 to the power m, this plus 3 goes to the numerator and becomes minus 3. 2 to the power m minus 3 equals to x upon 8. So the answer for this 2 to the power m minus 3 is x upon 8. So we were asked to find the value of 2 to the power m minus 3 in terms of x. So the answer is 2 to the power m minus 3 is x upon 8. This is the answer, okay, x upon 8. I hope you got this. Now let us do question number 2 of 9. 2 of 9. So we are asked to express 5 to the power 3n plus 2 in terms of y. So we are going to use this equation, okay. Log y to the base 5 equals to n, because we are asked to express this in terms of y, isn't it? We need y. So log y to the base 5 equals to n. Since log y to the base 5 equals to n, this is in logarithmic form. We will convert this into exponential form first, okay, and then we will express this. Or 5 is the base here, so 5, this n will come here as power, equals to this y will go to the right hand side, isn't it? Now this is converted into exponential form. Now we need 3n, isn't it? So first we cube both sides, okay, cubing both sides. 5 to the power 3n equals to y cube, cubing both sides. One thing must be kept in mind: whatever we do in the left hand side must be done in the right hand side as well, okay. If you cube in the left hand side, we must cube in the right hand side. If you square in the left hand side, we must square in the right hand side. If you add 2 in the left hand side, we must add 2 in the right hand side. If you subtract 2 in the left hand side, we must subtract 2 from right hand side. If we divide 2 by 2 in the left hand side, we must subtract by 2 in the right hand side as well. If we multiply by 2 in the left hand side, we must multiply by 2 in the right hand side as well. Whatever we do in the left hand side, we must do in the right hand side to balance this equation, so the value of this equation does not change, okay. So whatever we do in the left hand side, if we invert in the left hand side, invert means if we bring the number from the denominator to numerator and numerator to denominator, we must do the same thing in the right hand side. We must bring the number from the denominator to the numerator, and we must take the number from the numerator to the denominator in the right hand side as well, okay. So here I am cubing both sides of this equation, okay. 5 cube, n was already there, 5 cube, so y cube, n was already there, so I write n here, because we need 5 to the power 3n plus 2, isn't it? So we need plus 2 as well. So this means 5 to the power 3n, okay, 3n into plus 2. We need plus 2. This means 25. We multiply both sides by 25. Y cube into 25. I'm multiplying the left hand side of this equation by 25. The same thing must be done in the right hand side as well, okay, multiplying both sides of the equation by 25. So this means 5 to the power 3n into 25 means 5 squared equals to 25 y cube. 25 y cube into 25 is 25 y cubed. Or now see, 5 and 5 bases are equal. This means the power should be added. 5 and 5, the bases are equal, and there is a multiplication sign in between them, so power should be added. 5 to the power 3n plus 2, okay, 3n plus 2 comes here, equals to 25 y cube. Now we are asked to find the value of 5 to the power 3n plus 2, 5 to the power 3n plus 2, and the value of this is 25 y cube, okay. So this is the answer. 25 y cube is the answer. I hope you got this. Now let us do the next question. This is question number 10. So this is the given condition. If log x to the base 2 equals to a and log y to the base 3 equals to a, okay, these two are the given conditions. Log x to the base 2 equals to a and log y to the base 3 equals to a. We are asked to find the value of 72 to the power a in terms of x and y. Express 72 to the power a in terms of x and y, okay. We are asked to find the value of 72 to the power a in terms of x and y. So let's do this. So we have log x to the base 2 equals to a. Since log x to the base 2 equals to a, isn't it? So this is in logarithmic form. We convert this into exponential form first. Or 2 is the base here, so we write 2 here. This becomes power a equals to x. So 2 to the power a equals to x. This is equation 1. Okay. And here we have, since log y to the base 3, okay, log y to the base 3 equals to a. So let us change this equation also to exponential form, or this gives us 3, base is 3 to the power a. This becomes power equals to y. Okay, this is equation 2. Now we multiply equation 1 and 2. Okay, we multiply equation 1 and 2. Multiplying equation 1 and 2, we get 2a into 3a, isn't it? 2 to the power a into 3 to the power a equals to x into y. Okay, 2 to the power a into 3 to the power a. This is 3 to the power a. Left hand side multiplication, right hand side multiplication. Okay, now 2 to the power a is x. Okay, 3 to the power a is y. So what we do now is we need 72, isn't it? So first we must think that something into something must give us 72, isn't it? So we have 2 and 3. 2 can be made 8 and 3 can be made 9. So 8 9s are 72. We need 72 here, isn't it? So 2 can be converted to 8 and 3 can be converted to 9, isn't it? So 8 into 9 gives us 72. So I hope you got my idea. So 2 cubed, I'm cubing 2. Okay, 2 cubed a means here we must cube this x also, x cubed. If I cube 2, we must cube x. Okay, into 3 squared a. 2 cubed means 8, isn't it? 2 cubed means 8. Here we have 8. So 3 squared means 9. 8 into 9 gives us 72. 3 squared a is already there, a. So here we have y into, so I have squared this 3, so it means we must square this also, isn't it? So 2 cubed a into 3 squared a equals to x cubed into y square. Are you getting me? Since we have 2 to the power a, so I need to make this 2 8, isn't it? So to convert this 2 to 8, I must cube this 2 cubed. If I cube this 2, I must cube to the right hand side as well. So x cubed. So 3, if I want to convert this 3 to 9, I must square this. 3 squared is 9. So if I square this number, I must square this y also. So y squared. Okay. So 2 cubed is 8 to the power a into 3 squared is 9 to the power a equals to x cube into y cube, y square into y square. So 8 into 9, same power, isn't it? So I write 8 into 9 to the power a. So here we must write or. Okay, or 8 and 9 have the same power, so 8 into 9 a, power is a, equals to, if I have a into b whole square, this means a square into b square, isn't it? So a square into b square can be written as ab whole square. Similarly, 8 to the power a into 9 to the power a means 8 into 9 whole to the power a equals to x cube y square, isn't it? Or 8 9s are 72 to the power a equals to x cube y square. I hope you got this. So the value of 72 to the power a is x cube y square. Okay, so this is the answer, x cubed y square. I hope you got this. Now let us do the next question. Okay, now let us do question number 11. Solve for x. So this is the equation given to us. Log x minus 1, no base, okay, plus log x plus 1, no base, equals to log 1 to the base 2. This is the equation given to us, and we are asked to find the value of x from this equation. Okay, so since, let us first write this equation. Log x minus 1 plus log x plus 1 equals to log 1 to the base 2, isn't it? So first let me write some rules of logarithm, which we have already discussed in our previous video, but I am writing this again to remind you. Okay, the first thing we must understand, or we must know, is if base is not mentioned in log, okay, obviously in logarithm, if base is not mentioned, okay, then the base is to be considered as 10. Okay, suppose if I write log x without any base, there is no base, means the base is 10. Okay, if there is no base, if base is not mentioned, then we must understand the base is 10. If I write log 2, okay, no base is not given here, then we must understand the base is 10. Okay, like if I write 2 here, what we must understand is there is 1 in the denominator, isn't it? If there is no number in the denominator, means 1 should be in the denominator. Every number has 1 in the denominator. So if there is no sign in front of this 2, we must understand there is plus sign in front of 2, isn't it? And if there is no power mentioned here, like 2 square, 2 cube, like this, if no power is mentioned, we must understand the power of this 2 is 1, isn't it? All these informations are to be understood. Okay, there is not written information like this. What I mean to say is, if I write 2, it is to be understood that there is 1 in the denominator, there is plus sign in front of 2, there is power 1 of 2. Okay, power is 1. This is to be understood, isn't it? Similarly, if I write log m and base is not mentioned, we must understand the base is 10. If base is not mentioned, then the base is to be considered as 10. This is the first thing which we must know. We have already discussed in our previous video, isn't it? So the next thing is, if log m plus log n, okay, this is the first rule I am writing. Log m plus log n, if there is plus sign in front of two logs, log m plus log n, then what we do is log m into n. Okay, if there is plus sign, we must multiply this m into n. This means log 2 plus log 3 is not log 5. Okay, log 2 plus log 3 is not log 5. Log 2 plus log 3 is log 6, isn't it? Log 2 into 3, that is log 6. Are you getting me? Yes. If there is plus sign, we must multiply. And if there is minus sign, log m minus log n. Okay, if there is plus sign, we must multiply. If there is minus sign, then we must divide. Log m upon log n, log m upon n. Okay, and the last thing which I want you to know is log of 1 to any base is always 0. Okay, log 1 to any base is always 0. Any base means base should not be equal to 0, except this condition, base is not 0. Log 1 to any base is always 0. This must be kept in mind. Okay, now let us solve this question. We have log x minus 1 plus log x plus 1, isn't it? Bases are not given, so the bases are 10, isn't it? Okay, now log m plus log n, log m plus log n, isn't it? Log m plus log n, plus sign is in between them, so we must multiply this. X minus 1 into x plus 1 equals to log 1 to the base 2. So log 1 to the base 2 is log 1 to any base is always 0, isn't it? Log 1 to any base is 0. So no need to write this. So we write 0 straight away. So this is x minus 1, x plus 1. Let us assume this x as a and 1 as b. A minus b into a plus b. So a minus b into a plus b is actually a square minus b square, isn't it? So, or log a minus b into a plus b is a square minus b square. X is a, 1 is b, a square minus b square. But 1 square is always 1, isn't it? 1 raised to any power is always 1. So we don't write the power of 1 here. Okay, equals to 0. So now the base is not mentioned here. This means the base is 10, isn't it? The base is 10. Now this is in logarithmic form. Let us convert this into exponential form first. Okay, now this 10 is the base here. So 10, this 0 comes here as power, equals to x square minus 1, goes to the right hand side. Now we have 10 to the power 0, isn't it? So 10 to the power 0 means any number, please keep this in mind. Okay, any number raised to power 0 is 1, except 0 to the power 0 is not 1. Except this condition, 0 to the power 0 is not 1, 0 to the power 0 is undefined. Other than 0, any number raised to power 0 is always 1. This means 100 to the power 0, 1, x to the power 0, 1, m to the power 0, 1, isn't it? 1 to the power 0, 1. Okay, so 10 to the power 0, 1 equals to x square minus 1. Now let us bring this minus 1 to the left hand side. 1 plus 1 equals to x square remains in the right hand side. So x square, now let us bring to the left hand side, equals to 1 plus 1 is 2. This plus x square becomes minus x square, plus 2 becomes minus 2, minus minus cancels out, so we need to write that. So now let us take this square to the right hand side. X equals to square when taken to the right hand side becomes root under 2. So we were asked to find the value of x, and the value of x is root under 2. Okay, I hope you got this. Now let us do the next question. Question number 12, the last question from this exercise, exercise 80. If log x square minus 21 equals to 2, show that x equals to plus minus 11. This means this is the given condition. Okay, we are asked to find the value of x, and we are asked to prove the value of x to be plus minus 11. The value of x can be plus 11 or minus 11, plus minus 11. Okay, so let's do this. Since log x square minus 21 equals to 2, isn't it? So the base of this log is not given, isn't it? Base of this log is not given, means we must understand the base is 10. If the base of log is not given, then we must understand the base is 10. Okay, so this is in logarithmic form, so let us convert this into exponential form. Or this base 10 remains as base, this power comes here 2, this number goes to the right hand side, x square minus 21. Okay, I'm changing this into exponential form. Base 10, this becomes power, this number goes to the right hand side. Or 10 square is 100, minus 21, let us bring to the left hand side, plus 21 equals to x square. Okay, 10 square is 10 times 100, minus 21 becomes plus 21. When we bring this number to the left hand side, x square is in the right hand side, x square. Now let us bring this x square to, to the left hand side, becomes minus x square, isn't it? And this 121 when goes to the right hand side becomes minus 121. So minus and minus cancels, no need to write the sign, isn't it? This becomes minus x square, this becomes minus 121, minus minus cancels, so we don't write sign. Okay, so x equals to square, we take to the right hand side, becomes root under 121. So this is actually x equals to 11 into 11, 11 is 121, or x equals to plus minus 11. whenever a number is freed from root, the sign is plus minus. Okay, we must keep in mind. Root under 4 means plus minus 2. Root under 16 means plus minus 4. Root under 64 means plus minus 8. Okay, sign is not fixed, plus minus. It can be plus or it can be minus, plus minus. Therefore, whenever a number is freed from a root, plus sign and minus sign both we write. Okay, I hope you got this. So this is the answer. This is proved. The value of x is plus minus 11. Thank you so much. Stay connected. We will continue exercise 8b in the next video. Okay, thank you.